Aha, we are now recording, even without Matt. So
Right.
it turns out if once you become host, when the host drops off, then down at the bottom, along the buttons along the bottom on the right hand side, one says record. So I hit record, and away we go. So today I was playing with, actually the last couple of days I was playing with my Muse, and I posted something sometime last week saying that I wanted to get a whole pile of IMUs and hook them all up at the same time and try them out. And I was going to start with the Razor IMU from SparkFun because I had several of those. And the more I look into it, they're just a mess. So I try to figure out what order to get stuff in, what files you need to compile. And then I looked around. We've got this Fidgets, and Matt Sadowski just posted something saying he got a Fidgets IMU running, and he showed a little video of it. I thought, well, I've got one laying right here that we have used, and I should have had code on my laptop to talk to it. So I plugged it in and tried it, and my laptop wouldn't talk to it for whatever reason. And it's code that we had hacked up for whatever reason. I don't know. We were probably changing directions and transforms and all that kind of stuff. And I needed it on a different computer anyway, so I pulled up my Raspberry Pi from my robot, and that's what I've been compiling all my other drivers for. I just was able to go out and download the driver, the official driver from, just went to the ROS webpage and followed the links there and downloaded the, whatever, it might just be called IMU driver, whatever it was called. I downloaded that, and I had to copy the launch file from there into my directory. So I had a launch file. And then it has a serial number built into the thing, and I think it says it puts in a -1, and it could be a -1 will go with any device that it sees. So anyway, I changed the serial number to match mine. I started it up, and it seemed to be working. And I fired it up on RViz, and let's see if I pull up this screen here, screen 2, and I want to start with the other picture here. Since I'm talking about that one, this is the Fidgets IMU that shows up on RViz, and you can move it around and it tracks relatively well. I think over time it was drifting a little bit. And one problem I have is if I rotate, I didn't make any movies of this, so I can't show you movies of it acting or of it moving. But as I'd rotate the thing, if I'd rotate it, say over to here, and it seemed to follow fairly quickly. But then when I'd come to a stop, then the IMU itself would either drift positive or drift negative away from where it stopped at. I assume that's due to magnetic calibration. It's picking up it thinks I'm pointing in the wrong direction. It's trying to correct for that. And I haven't done any of the magnetic calibration on it other than I did this weekend go through and found on the Fidgets webpage, you can get the calibration code that'll run under Windows, and you can also get something that runs under Linux. So I downloaded the Linux version and compiled it. And when you run that, you can either do 2D calibration or 3D calibration. So if you're going to put it on a vehicle like a tractor where you can't pick it up and flip it around, what you do is you set it to 2D calibration, and you either drive around in a circle or drive around in figure 8 or something. So it expects the vehicle is going to be flat the whole time, and somehow it takes that into account. Anyway, I ran it at home, and I didn't have the IMU, and it looked like it was going to work. So I came to work today and laid it on the table and ran it, and it finished the calibration, and it said it wrote the values into the IMU, so theoretically it's calibrated, but it still didn't work quite right. But it's laying on my desk at work, so I can't really expect it to do a whole lot. And the point is, what I need to do is bolt it onto the machine and then do the calibration, and then I can see if it's going to maintain, if it's always going to know what direction is north. And that's my problem right now. That seems to be drifting. So then if I go back to my other picture I had here, so this is the which one was this? This is that board from that we bought on Tindy, and it's by Chris Weiner, and he found this motion processor chip called an EM7180, and then you can buy it in one of two versions. You can either get it with the that MPU 9250 from Invensys, or you can get it with, I think the other chips are from ST Micro. So it's got your 3-axis accelerometer, gyroscope, and magnetometer. Plus it's got a barometer chip, and there might be one other thing on it, but it gives you all the stuff that you seem to need. And then Matt at one point had downloaded a a driver from somebody. So he's got, if you go out on the Droder GitHub, it's got all the code to run this. So you just simply load the code on a Raspberry Pi and wire it directly to the sensor over the I2C bus, and then it will talk. So after I got it running, this is a screenshot of what it's doing. So up here at the top, this was the IMU data. Where does it say here somewhere? I guess it's not labeled here, but this is the IMU/data topic, and the one down here is IMU/data underbar raw data. So this, I think, is right off the values right out of the accelerometer and the gyroscope. And they said specifically it does not put an orientation in running in this mode. And then the one over here is just showing the magnetometer output. So it's showing you the 3 axes of magnetometer values. And this up here is the software they provide with it. And when it's running, these numbers are always flipping around, and the thing seems to be quite stable. But if I leave it there, sit on the desk for 10 minutes or whatever, this box will it'll rotate around by say 90 degrees or something. So there's something wrong there. And again, I need to do calibration on this one too. So the point was that first image I had, I'll go back to that one. And this is actually both IMUs running on that Raspberry Pi at the same time. So this is showing the one from the EM7180, and this is showing the one from the fidgets. So I can move each one independently, and they move on the screen. And so now I've got 2 of them physically running. I can get them bolted on, and then I'll have to go from there and decide, are they adjusted well enough, or do I need to do more to that? So that's kind of where I'm at with that project, just trying to play with that. And I spent half the day trying to get my Raspberry Pi, get the I2C to work on it. And you go out on the internet, you track down these things. It says, oh, try this, add this, download this. And it turns out that they told me to update a file and put in something called like CT param underbar I2C, and then to turn it on. And I changed that in the file, and that didn't seem to work. Somewhere else it said do that and put I2C1 on there, and that didn't seem to work. And after all day of screwing around, I realized that I'd left the pound sign, the hash sign on the front of the line, because I just assumed that somebody come up with yet another format for files. Because I looked down the line, and every entry in that file had a hashtag in front of it. So I just assumed that had to be there. But no, that really is a comment like it's supposed to be. So once I took those off and started running, that got it working. So really, both of these will load up fairly well and actually work. So I guess that's kind of the point I'm at right now, and I can't think of anything else I did between now and last Friday, which we had the lawnmower meeting last Friday, and I talked about a bunch of stuff I was doing, but this is the new stuff that I've done for now. And I guess that's all I got to say, so I'll turn it over and see, did Matt ever come back? Can you talk now, Matt?
No idea. I think I have about 3 minutes and then it reboots.
So let's see.
Thanks for going over that.
Okay. Alan, do you have anything you want to present?
Yeah, I think, let's see if Matt, why don't I go ahead and share my screen here. So can you see that now?
Yes.
Okay, so I have fidgets here as well. And so I had a question on that. Well, a couple questions here. So let me just go through. So let me move all these over here. So the control panel is here. So it has these 4 different components, all within the same device. So it's a 3x3, and I just got the basic version. I didn't get the advanced version. So it has those 4 different things. And if you just double click them, then they open up into their windows here. And I think it's pretty good. A couple of things here I had questions on. So on the gyroscope, this is the drift you were talking about. See how this one is, I'm holding the device completely still, but you can see that it's drifting.
Which screen are you looking at?
Oh, sorry, the gyroscope screen.
Okay, that one.
X,
Okay.
yeah, the X position right here is slowly heading towards, seems to be going, what, clockwise? And I'm holding the device still. I'm not moving it. So I don't know. I don't know what to do with that. Jeff, any ideas on that? I mean,
Looks like your X and your Y are both slowly moving, and your Z was moving faster. I I just now got mine running, so I'll have to dig into it and see what I can make that do.
yeah, it's like if I tip it, what is that, a quarter of a turn, then on the Y position, it's pretty accurate in terms of now I'm tipping it the other way. And you go the X direction or let's see, which one is Z here? Z must be, I don't even know which one is Z. Z is just kind of rotating it. So it's pretty good. But that's probably the one I'm seeing the most challenges with is the gyroscope. And then it has an accelerometer, which is measuring the G-forces. And this is one, I think if you go with the more advanced fidget, I think you'll get a better deal. These are kind of coarse measurements. You can see if I tip it on its side, then it goes to 1. These are G's, G-forces. So it's 1 G because it's tipped on its side. But if it's flat, then this one is on the, I guess if I flip it upside down, then it's negative 1 G. So it's pretty good, but it's between 0 and 1, it's not very fine-tuned. But the advanced accelerometer they sell, that is a lot better in that regard.
Is yours the 1042 that it says on the screen there?
Yeah, right here.
Ours is the 1044, so it might be what you're calling the advanced one.
Yeah, I think on your accelerometer screen, you probably have 2 dials here. One is more fine-tuned and one is more coarse.
Well, that's possible, but I've never run this software. This is the first time I saw a reference to this somewhere when I was going through, but I just fired it up. I'm just running the ROS drivers on it directly. So I've never tried their software.
Okay. Yeah, it comes with this control panel as the starting point and then go from there. But this one, I'm not quite sure I understand the magnetometer yet. Over here, I see a compass bearing, and that seems to be pretty stable. So if I rotate it, the compass, I don't know what resolution this is, but it seems to be pretty good. As I turn it, it's pretty accurate. I didn't know what this means. Any ideas what this means? Gyroscope headings. It's got 3 different dots, and as I move, I guess maybe it's X, Y, and Z, and I don't know what they're.
I'm not sure
It's
why.
kind of weird.
Yeah, I don't know why they call it headings, unless if you tilt it forward to say whichever color is.
Yeah.
I guess you have to pull up that other.
For me, when I tip it forward, then the red one seems to move the furthest. If I tip it side to side, then it's the green one. And
it probably just simply means they've integrated the rotational velocity, and they're going to call it a heading. So it's really just the angle the thing is pointed. Whether when you turn it in the Z-axis, then it goes north, east, south, or whatever. And if you have it laying flat, and you tilt it forward, then it's going to, if you tilt it and point it down, it's probably going to say that's 90 degrees, either plus or minus, whichever way it is. So I think it's just simply, they're calling it a heading because they've converted that number into an angle. And that's why they call it a heading.
Probably taking this, I would guess it's this data, the gyro data.
Those numbers right there are numbers in degrees per second. So if you take those and integrate those numbers together, that becomes an angle. And let's see if we look at roll pitch, pitch, roll, and bearing. So if you look at the bottom column over there on the left, those numbers, that's the one, as it takes those numbers and integrates them and creates those angles there. So it converts the rotational rate into an angle, and that's what that's showing you.
Yeah, you need those angles to correct the bearing, right? Because if you tilt it, then the compass doesn't read accurately.
Oh, I gotcha. So anyway, I guess that's what I know about it. I mean, it's kind of nice to do some troubleshooting using these windows, but typically I use Java or Python and go directly into use code to pull this data, and then I can store it, and that kind of stuff. If I was able to get over to ROS, then I'd use ROS to do that, I guess. So one thing I've mentioned a few times, I've been working on a greenhouse. These are a few weeks ago before we got cold and snow, but you can see it's pretty basic, pretty small, but it's a hoop house with double layers of plastic. There's a side view. And I think this is only one layer plastic. Now it's got two on it. So you can just see what that looks like. It's not very big on the inside, but it'll give me a place to work here in the wintertime instead of waiting till spring. So that's that. And then I did get a video back in October. This is the rover and driving here. And you can see I'm sitting here with the computer screen. I'm recording the computer screen as well as the rover over here. So I had my hands full, so I didn't get a very good, I didn't do much that day. So like here were the onboard cameras showing up on my computer screen, for example.
So is this robot going to be used inside of your greenhouse or out in the field, or is it just something to play with?
Well, I'm just using it in the greenhouse, so I've got a place to work with it in the wintertime. The idea is that I would use it outside in the summertime. I guess you could use it in the greenhouse. It would work just fine in there as well.
What are you using to transmit I think the video back? This is the one you showed maybe like 5 weeks ago. Is that right? Something like that.
Yeah, probably, maybe even longer than that. So I'm using, I put in a Ubiquiti network with a switch and access points.
Okay. Like one of the, is it a Omni antenna, or do you have like a directional that you're going to use?
No, I don't. So I think I do have a mesh so that I can go. One of the access points wouldn't have to be connected to an Ethernet cable, so I can get a little bit further that way. But I think range is going to become a problem. So I think I probably need to look at some kind of a unidirectional at some point. I'm just not quite sure how to go about that yet.
I think like they make like the Rocket M5, I think works with the Ubiquiti stuff. And they have like a higher gain Omni antenna. So you might, I'll see if I can find something and post that. But I kind of have the same issue. I would like to get video, and cellular is maybe not, an option because of the cost of it.
Yeah, that was my first attempt. I thought we could go with cellular, and it worked. Well, I couldn't get enough bandwidth because I think I have 4 cameras, 5 cameras, something like that, plus the data to the computer. It has an onboard computer up here on top, and so by the time you get all of that video traffic, I could hardly communicate with the computer, and so. Again, part of it's our location. We're out pretty far, rural, and so we don't get good cell phone coverage. I think if you're closer to a tower, I think you might be okay, or a lot better off anyway. But I can get. Let me think about this. I should be able to get 600 feet which is pretty good. So the first access point would have to be on a cable, and then the second one mesh. I think I could probably do 2 hops with mesh, but I think I haven't tested it yet. Let me just put it that way. These access points are supposedly able to mesh without very much loss in traffic. The old access points, you lose half every hop, but these access points aren't supposed to drop any performance as you go from hop to hop. So we'll see.
There's also the company called Mimosa, I think, and I think they make some MIMO products that are longer range.
Okay, Mimosa.
Yeah, you gotta watch the spelling because I think it's also a drink, right? Yeah, MIMOSA.
Yeah, there you go.
I don't know. Does anybody have any experience with the LoRa products, like the protocol?
I haven't heard of that before.
But it's supposed to be longer range Wi-Fi, but they lower the frequency to like 800 megahertz range, 400 megahertz range, and so it transmits over a long distance. I guess it's up to, I don't know, like 2 kilometers or 4 kilometers or something. I don't remember what the exact amount was, but I don't know what the bandwidth actually is on it.
I'm using those for my remote control, and I get enough range that, so far I haven't run it out of range, but I haven't really, checked to see how far it is. Somewhere they claim, they say with the proper antenna, you can get like 14 kilometers or some ridiculous number. I don't know if that's really true or not. But as far as you're asking about the bandwidth, it's slower than I expected it to be. And I just simply bought boards from Adafruit. But let me complain here for a moment. I was trying to watch a guy's video on on an IMU, and he kept saying Adafruit. He kept saying Adafruit, Adafruit, Adafruit. I said, no, it's Adafruit. My Aunt Ada's going to come over and smack him in the head for saying that. So anyway, I bought these boards from Adafruit, and it was like a Cortex M0 processor and the LoRa radio right on the same board. And I just took their example code, which I think they're pointing to somebody else's example code. So you basically fire up an Arduino type IDE, and you load in the libraries for this, and you say, make one a transmitter, or you make one the master and one the slave, basically. And I just simply said, put it in a loop. I said, read all the values from my remote control, which I had 2 joysticks and some several switches. I just took those values, put them into a packet, said, transmit that. And it seemed to take a significant amount of time for that to come back, because it goes to the other radio, it then receives it, and then looks at I don't know how much error checking it does, but it does a little bit of error checking. Then it sends a message back, like an acknowledgement packet, which actually sends a group of data back. And I expected that to all go fairly fast, but I found out that it seemed to go slow, and I kept taking my loop delay out, and I can probably only get it to go like 100 millisecond loop running there. I can't get it to run any faster than that. And I just assumed I could push a lot more data through it than that, but it doesn't seem to. So it's a fairly slow thing, and I'm only sending like 8 to 10 bytes in a packet, so I'm not sending huge amounts of data over that. And other than that, I haven't really played with it, other than it seems to work great on my remote control. I turn it on, it works, and when I turn it off, it works. And so that I'm happy for what I'm doing with it. But like Al was trying to push correction data for his GPS over a radio, and he went with those. And I can't think what those are called. Like the telemetry radio they use on Pixoc and those kind of things. he used a pair of those, and those simply, it's like a serial port on one end and a serial port the other end. You push data in one side and it just comes out the other side, and those don't seem to have a lot of delays or extra problems with those. And I don't know what the range on those is either.
Yeah,
That's pretty much my expertise. So
yeah, it sounds like video is a no-go over it, I guess.
I would say no. I don't think you can push video over either one of those types of radios.
Yeah. So still a problem to solve.
Let me put out a question for Matt. When we're done here, does somebody have to turn off the recording, or does it just take care of itself? Or, well, I guess we know if we don't turn it off, it could run for say 3 hours, like it did one day. But so somebody, is it best if somebody hits the stop recording? Then do you have to do anything else, or is that all it takes?
Yeah, just hit stop recording at the end.
Okay. So if I'm still the host at that point, I'll turn it off.
Okay.
Well, I'm happy to flip through what abysmal slides I do have if we want to do that. I've just got a couple of them that I was trying to quickly put together before the meeting. Seems like I never have enough time for this project, but I don't know if you can pass me presenter and I'll flip to the PowerPoint thing that I probably have spelling errors and everything else in.
So the share screen button is at the bottom of the Zoom window.
Oh, I see. Thank you. Okay, does that work?
Yes.
Okay, so yeah, my project is a no-till and tillage and forage production application. So the idea is to plant with it using a no-till drill, which has a monitoring system, occasionally disc or apply fertilizer. And then I'd like to be able to sort of unbolt most of the main components off of it and bolt them on a different tractor at some point to be able to drive either a swather or a baler, those sorts of things. For right now, to start with, I want to keep some of the components interoperable with AgOpenGPS, just to have a ability to quickly revert to an auto steer setup that works. And then it's got to be low cost, and I'm trying to kind of standardize up on things. So that's why I've been exploring like ISOBus protocol and how to sort of interoperate with the equipment that I have available. And then I want remote operability, or in some cases, the ability for the operator to be able to assist or just monitor the conditions, and I'll explain why that is. So I've got a Cat Challenger 65C that we bought a few years back that I'm trying to outfit with this stuff. It's like a 300 horse, 285 horse tractor, closed center hydraulics, 4 service ports, and it's a tracked system. If you haven't drove one of them before, it's the steering wheel in it. It has a steering wheel. It's actually a GM, like 1980s GM steering column. And in order to steer it, you turn the steering wheel in the direction you want to go, but there's kind of a hard limit, about half a turn to the left and half a turn to the right. And if you hold it, say at 10 degrees to the left, it'll keep turning in that direction until you recenter the steering wheel. So it works a little different than what I guess you would say like typical steering is on a vehicle or I think a number of the other things that have been kind of being worked with. I assume that like most of the ZTR lawnmowers that maybe you guys are controlling are kind of steered similar to this. So, so some problems with this, and then all the other equipment that I'd be probably trying to deal with, is that the monitors on the systems are generally inadequate for like when a breakdown actually occurs. So if you've been around farm equipment, especially older farm equipment, yeah, there's monitors on stuff, and if something catastrophic occurs, then like really catastrophic occurs, the monitor will go off. But if something small happens, you can really damage things pretty badly before the monitor goes off, if that makes sense. You know, the sort of idiot lights. So that's one kind of hurdle that in general I think that I've got that's maybe a little difficult to figure out, you know, how I'm going to deal with some of the issues surrounding that. This particular platform has a power shift transmission. Some of the older equipment has, for instance, quad range. And I know, like, for instance, Kyler had to deal with some of the other transmissions, so it'd be interesting to sort of, you know, have some discussions. But this particular one, I can shift it with the linear actuator. But discovering like exactly how that's going to work, I haven't made it all the way through yet. The implements that it's connecting with are ISOBus or some type of parallel monitor, or completely proprietary. Don't have a monitor at all. So there's I'll kind of like very briefly discuss like some ideas around that I'm working with, but kind of like how and why I'm picking a couple of the things that I'm doing. So this is the sort of first set of hardware. This is completely incomplete, but I'm just trying to get something together for the meeting. So I did get the Argus Simple boards and the radio that goes in between them for corrections. To run the steering wheel right now, I have an easy steer motor, which I'll talk about in a couple slides, and external ADC to be able to sample some wheel angle position on the steering wheel. I got the compass module that's the same, and this actually has an integrated barometric sensor too, but that's not really very important to me. It just happens to be on the board. And for a wheel angle sensor, I'm using a Delphi sensor out of they have them in GM vehicles, and they're used for ride height actually as well, and some semis and things like that. And I don't particularly have any ideas for odometry. So if somebody wants to throw out ideas, then we can discuss that. I thought about maybe putting like a roller wheel inside the track, or maybe some metal studs in the track to start with, and then read them with an inductive proximity, or some other ideas. Actually putting something on the drivetrain is a little bit problematic because it's pretty easy for the cables to get ripped off, and it I might be able to really sort of bolt some things down, but that's one of the big problems with like just running a proximity sensor out there and putting a gear on the outer part of the hub. So this is just sort of, I guess, the way that AgOpen GPS does it. For, I imagine most of you guys are probably familiar with this, but I've got one of these IBT2 motor drivers to run the steering motor, and I have an Arduino, and then the inclinometer IMU, and then the analog digital converter all connect to it, and then the wheel angle sensor is connected in the analog digital converter. And in addition to this, I also have available an encoder, which is probably a lot better for sensing the fine movement of the motor, but not good for actually sensing the real wheel angle position of the steering wheel. And that's because, I guess on the next slide here, if you're not familiar with it, this Easy Steer motor, we had it on a previous piece of equipment, so I just reused it because the ability to like put it down onto the steering wheel and take it back off of the steering wheel for when you want to operate the vehicle without the auto steer setup's quite simple. So the issue though is that it has a foam rubber wheel that tracks on the main steering wheel. So if it gets off a little bit, then the internal encoder that's in this guy reads off to the side. So that's why I need like an additional sensor on the steering wheel in order to tell the true angle and make sure it gets returned back to the middle position. So no magic there. So this is kind of like the 10,000 foot view, but this is like a really bad slide. In general, I wanted to start with CAN bus is the communications that most of the modules use, and the reason for that is that eventually I want to migrate into something like J1939 because that's what the most of the heavy industrial equipment uses, and what the basis for the ISOBus protocol is based on top of. So for now, I'll start with that in between the modules, and then move into something else. And so, for instance, like the steering box that I'm putting together, it'll support USB to be able to support Ag Open GPS. But then when I connect it to ROS, I'll be doing that over a CAN shield from the Arduino. And right now for the tele-op, I've got a force feedback steering wheel and pedals. But I don't really have any great ideas for how to control the throttle from that. It would seem straightforward to run it with the foot feed, but I think in practice, if you're using it as a tele-op, that you wouldn't actually want it to be on a pedal because you don't want to hold your foot on it for hours. So the mechanism for how the throttle actually gets increased or decreased, I guess, is for discussion. So anyhow, that's kind of the project, I guess. At least what I have in slides. So yeah, I don't know if anybody has ideas or discussions for the odometry or anything else related to it.
That looks really good, though. It's really good. Did you say you would have some kind of so your teleops? You have a handheld controller, or are you going to run it off of a computer?
I'm going to run it off of a computer. So I kind of envision that piece of it always being like either indoors or in the back seat, for instance, of a pickup where I've got a lot of space. Sure. Yeah, because if you're able to run it remotely, you're not being jarred around inside the vehicle for things that require monitoring. There's a few things that in general, like if you just have a set of eyes on it, that it's a good place to start. And then, like I said, that the things where monitoring are inadequate is typically the problem, and where you'd kind of need a human watching some of the stuff, at least until I get more monitor type equipment put together. Some examples of that are like, for instance, a baler might have pretty good parallel monitoring, but there's not, like the one we have, for instance, there's not particularly an easy way to get that monitoring into ROS without building a parallel interface box of some sort and some custom code for it. So if I want to do some of the baseline stuff where you would run until a signal goes high and then you stop and dump the bale all autonomously, I would still need somebody in the loop at least to start with for like when an error occurs, like if for instance the net wrap on the baler doesn't function correctly, or in the case of big square balers, like some of the individual knotters might not tie on rare occasion. So
Yeah, I've learned that too, that you can get started, and if you get to 90% performance, the 10% starts to come around pretty fast. So even if you're at 95% performance, you're facing issues quite often. And so to get to full remote operations like you're talking about, you have to be at, it has to be over 99.9. You got to be up in the 4 or 5 nines to make that work, and that gets to be pretty expensive and pretty tough to do.
Yep.
For you,
So-
you said you may not need what you have your GPS, and then you have to put in.
We're not getting it.
You're breaking up there. Yeah. Can you repeat that?
I'm just saying that odometry is just X, Y, and yaw. And it's going to have some movement, but since you have an RTK GPS, you always know how far you are. You always know your position. If you can get your orientation from your compass, then you'll have odometry message.
Yeah, and that's so from the previous discussions we've had here, and like for instance when we were talking with Kyler, I think it was months back now, that was also kind of my take on it, that I like the, I guess, traditional odometry where you guys are measuring the wheel encoder counts isn't really necessary, but I would still like it to know, for instance, if there's track slippage and that sort of thing, and to maybe potentially assist with steering. But I don't know. I don't have any. I'm going to get some stuff working first and then add it, but I don't know a great idea that would just work to start off with. I might have to just play around with some things. But it's kind of a, if you look at this, you would think, okay, well maybe I can run a cable, for instance, through the track over the bogey roller. Well, that area, big weeds and things like that come through it on occasion, and it's real heavy, clouded with dirt. So there's not really like a good way to get around to the inside of a hub and put an arm on it, and the other side where the axle is, you can potentially go through, but again, there's a lot of stuff that comes through over the top. For some reason, the tracks really just wrap stuff around in practice. So there's a couple other things. I've got like a fuel shutoff solenoid for it, for safety shutoff. And I think we had some discussion in one of the threads on the Slack where I'm really gun shy about ever actually using that shutoff solenoid, because you completely lose steering. whenever the engine goes off. So, and I haven't found a good way to tap the brakes besides actually using the pedals so far. I really need something that runs in parallel with the brake system, because in idea, right, you push down the brakes and everything works, but in practice, you push down the brakes and they might need more application or less application. So there's not like a pressure feedback on it, if you know what I'm saying, like
Right.
so which I guess I could do get a linear actuator that had some type of force feedback on it. But
if you drove your tractor and popped your seatbelt, what happens?
the seatbelt?
Yeah.
Nothing. No, there's no seatbelt monitoring in this.
Okay. Do the whole thing.
No.
That was the first thing to go, right?
I don't notice that this ever had one, actually. I mean, it's pretty simplistic from the electronics side, because it's not electronically operated injection pump. It's a mechanical injection pump. Most of the logic for like warning lights and internal operations for like cab controls are all done on really basic relays. Caterpillar, like when they designed it, made it really simple, and didn't put a lot of sort of bells and whistles in it. That's nice to be able to interface and read what's there. But for things like, you push the go button and it goes, that button doesn't exist. You have to make the go button. So, but I figure if I can solve it with this, then some of the other tractors that are out there are easier. And then the other thing is, for inexpensive agriculture, these can be had for pretty cheap now. So same way with other power shift systems of their era. So anyhow, it's my little project, I guess.
Have you tried using that
That's
compass?
really good.
Have you tried using that compass module yet?
I haven't. I got them all in a box. I don't know if I've got a picture of that or not. And I got it mounted. So when we were talking the other night, for instance, about the offset that somebody was having when they had the unit rolled for their GPS, I actually have experienced that with an ag GPS, but then the way I mounted this, I, in my head, thought that they were together on the Argus Simple board because I have it right next to that same compass. So I'm kind of curious how that's all going to play together. And as soon as I get the compass up and running, I'll let you know. It'll probably be next week. So I've got it mounted basically in the same box as my my Arduino, and it just gets connected straight over the Arduino and then spits out the data in a serial string. That's what AgOpenGPS takes in from the Arduino. So yeah, should know pretty quick.
I was just curious if you'd used it yet and had any opinions on it. I just ordered a couple of those because of something I saw about apparently it's easy to do the magnetic calibration on it. And so I just wondered, since you'd listed it there, I just wondered if you'd used that yet.
Nope, not yet. You might be able to find some other info on the AgOpenGPS website too. Yeah, their philosophy, that I think the developer's Brian T or something like that's the guy's name. It'd be interesting to get him invited to one of these meetings. But their philosophy is that most of the guys that are running an auto steer setup don't want to do embedded development to get it to work. They want to plug a few things together and make it go. And I understand that from like a getting work done perspective. What would be interesting with this project and their project is if they maintain some level of interoperability. I think there would be a lot of people who could maybe be leveraged. Like you would have Ross Ag interoperability with people who have hardware running around the field. I guess is what I'm trying to say. There's no standard there, but there's a project which quite a few people run. So
do we have any other thoughts for the night before we wrap up here? We're getting close to the quitting time.
Well, good updates tonight. I appreciate it.
Yeah, it looks like everybody's got something they're working on and everybody's moving forward. And Matt's at a conference or demo or whatever, some kind of a show that he's at. So he's been posting a couple of pictures from that.
Yep, the Small Farm Tech Expo is interesting. It's going okay. Lots of small farmers out there growing vegetables. PSA type farms.
is there some sort of a registry for those guys?
Yeah, there's different organizations.
Be interesting to spam those organizations list with with some way to connect.
The Farmers Guild.
Yeah, you get a few farmers on the few more farmers on the Ross project.
Okay, one last call. Any final comments or should we call it a night?
I'm all good here.
That's all I have.
Okay, well, I'll see everybody next time then, or on Friday if you make it for the lawn tractor meetings that are Friday morning. So, see y'all later.
All right, guys. Later.
Have a great week.